And problem number 5, the last one. So here, instead of giving you a hint, I will just give you some background of where the inversion formulas are coming from. Okay, so you can read this part, this paragraph, but I will also explain to you some of the details. Okay, I'm going to do this over on my iPad. Okay, so here's inversion of hyperbolic cosine. Okay, so let's define hyperbolic cosine. Let's write this as cos of t is e to the power of t. So this is defined as e to the power of t plus e to the negative t all over 2. And in the problem, we set this to be equal to x. Okay, so compare this to the definition of sinh or hyperbolic sine, which is given as e to the t, e to the negative t all over 2. Okay, they look alike. The only difference is the sign there. Okay, anyway, so finding inverse means isolating t. Okay, so here we have x written in terms of t. Now we want to isolate t and write an expression of x. Okay, so that's what we are trying to do. And here's the algebra that goes under the hood. So let's multiply both sides by 2. Okay, and then multiply both sides by e to the power of t. Okay, so I get 2x e to the t equals e to the t squared plus 1. So I get e to the t squared minus 2x e to the t plus 1 equals 0. Okay, so if you introduce, you can introduce a variable capital T, say, then this is quadratic in capital T, t squared minus 2x times t plus 1 equals 0. So we can apply quadratic equation formula to solve for e to the t. So since we have 2 times something as a linear coefficient, we know that this is equal to x plus or minus square root of x squared minus a times c. Okay, so this is if you simplify everything, you'll end up with something like this. Okay, now here's the issue. We have plus or minus, and we have to be careful with this dual sign. Okay, so we need to understand what's actually going on with this hyperbolic cosine function. Okay, so as you can see, we have a part that grows exponentially, and we have another part that decays exponentially. You take the average of these two curves. Okay, so the graph of hyperbolic cosine will look like this. Okay, so this is t here, x here, x equals cos of t. And as you can see, this function is not, well, let me also point out that this has to be equal to 1, because when t is equal to 0, we get 1 plus 1 divided by 2, which is equal to 1. Now, as you can see, this function is not one-to-one. Yeah, we can find two distinct points that map to the same value. So this is not one-to-one. Therefore, you cannot technically find the global inverse. But what you can do is you can find the inverse of this branch or the other branch. Okay, and they correspond to one of these. Okay, so what you need to observe is that for x greater than or equal to 1, yx greater than or equal to 1, because that's what the graph tells us. For x greater than or equal to 1, notice that x plus root x squared minus 1 is going to be greater than or equal to 1. Okay, so when x is equal to 1, we get 1 plus 1 minus 1, which is equal to 0. So 1 is the smallest number. And as x grows, as x becomes large, this term will become large. It will increase. Okay, so this term is greater than 1. While for, excuse me, I didn't need to write that. What I meant to do was to use the create a second bullet point. While x minus root x squared minus 1. So this happens to be between 0 and 1. Okay. Yeah. 0 and 1. Okay. So close bracket to 1. This is something that you can confirm using calculus, but I'm not going to go over the details. Okay, so we are going to concentrate on this guy. Okay, so keep in mind that x minus root x squared minus 1 is between 0 and 1. Okay, with that in mind, let's invert. That is, let's solve for t. Okay, so using the root with negative square root or negative radical, we get e to the t equals x minus root x squared minus 1. So in order to isolate t, we apply natural log. So t is equal to log x minus root x squared minus 1. Okay, so this is the formula that you see in the problem. Okay, and you have to compare this against the conventional formula for arc cosine that you see at the end or at the front of your calculus textbook. Arc cos is usually given by log x plus root x squared minus 1. Okay, and you now know clearly where this is coming from. This is coming from inverting this branch of the cosine curve, and that's what the textbook uses, but this is the part that we are interested in this particular problem. Okay, so that's why we are seeing a slightly different formula here. Okay, so what happens in your case is that when you calculate, so we see that something funny is going to happen when x and square root of x squared minus 1 are very close to each other. Okay, So we see that numerically, when x is close to root x squared minus 1, when these two are close to each other, the calculation suffers from catastrophic cancellation. Because we are carrying out subtraction of two nearby numbers. Okay, so in the question, t is set to be equal to you are asked to set t to be equal to -4 colon -4 colon -16. So this is the vector, row vector -4, -8, -12, -16. And then you set x to be cosh of t. Okay, so this is cosh of -4, cosh of -8, cosh of -12, and cosh of -16. Okay, another row vector. And so these are x values. Okay, so take a look at one of these. Okay, now consider one of this. Consider, say, the last one, x equals cosh of -16. Okay, so this is going to be a positive value because cosh of -16 is e to the -16 plus e to the -16. So that's +16 divided by 2. This is going to be humongous. This is going to be really tiny. So this is almost going to be e to the +16 over 2. So huge. Okay, so this value is very large. Okay, and when x is large, x and square root of x squared minus 1 are no different. Okay, so I'm just pointing out that this happens when x is large, because if x is large, x squared is really large, and subtracting 1 doesn't matter too much. So essentially this entire expression is like square root of x squared, which is equal to absolute value of x. When x is positive, it's just x. Okay, so they will be very close to each other. So that's why we are going to see some very bad catastrophic cancellation. Okay, now I want to point out one more thing, and I will wrap up today's session. Take a look at the following. So here we are presented with an alternate formula for A cosh. Okay, so this was our first formula for A cosh, but this is alternative. I explained to you why this suffers from catastrophic cancellation when you calculate it using MATLAB. Okay, this alternately suggested formula will not suffer from such a thing because we are not going to have catastrophic cancellation even if x is very large. Okay, so I'm going to just show you where this formula is coming from, and we'll call it a day. So alternate formula. So it's really similar to those examples from lecture. where when you have to compute an expression that has negative, that involves subtraction of two nearby number, you gotta look for an alternate way to write that expression which avoids subtraction. Okay, so that's exactly what we are going to do, and I'm going to start with what we have from before. Okay, and let's concentrate on this part first. Okay, so I have x minus square root of something. So the natural thing to do is to multiply by the conjugate over conjugate. Okay, and since conjugate now has addition instead of subtraction, provided that the top simplifies to something that doesn't involve subtraction, we will be good to go. Okay, so let's confirm. The top simplifies to x squared minus x squared minus 1 divided by x plus root x squared minus 1. Okay, now we don't care about this subtraction because x will become large, and large number and small number, they are not nearby. Up here we get a nice cancellation, and we end up with 1 divided by x plus root x squared minus 1. Now allow me to rewrite it as root x minus 1 times root x plus 1. Okay, I factored it and split the radical. And here comes a little bit of algebra. Before I do the algebra, let me multiply both top and bottom by 2. This. And then if you set a to be root x minus 1 and b to be root x plus 1, then you'll notice that a squared plus b squared is equal to x minus 1 plus x plus 1, which is equal to 2x. Okay, so with this, you can think of this as a squared plus b squared, and the bottom here, the second term here in the bottom is nothing but 2ab. So let's write a perfect square. So I get 2 divided by a plus b quantity square, but a is root x minus 1, b is equal to root x plus 1. Okay, so if I write 2 on top as root 2 square, then with this, I can write this as log, and let me write this as root x minus 1 plus root x plus 1 all over root 2. Everything square, but I flipped it. I flipped top and bottom. So not just 2, but negative 2. Negative 2. So that allows me to pull negative 2 outside, and I get log root, and let me combine the roots together. Root x minus 1 over 2 plus root x plus 1 over 2. And this is how you get the alternate formula. Okay, and as I advertised earlier, since there's no subtraction of two nearby numbers, this is going to be avoiding catastrophic cancellation. Okay, so that's what you should observe in your computation. All right. Okay, so that's all for this week. We are getting into some serious material. We are really starting to get into scientific computing and numerical analysis, and this is how the rest of the semester is going to, this is the tone for the rest of the semester. Okay, so up to this point we were quite easygoing because we are just learning this programming tool called MATLAB. Since we are now equipped with basic skills with MATLAB, we can now concentrate on dealing with some more serious mathematical work. Okay, so please keep up the good work, and I'll see you next week. Bye bye.